Hi, thank you for showing up on a Friday after the party. And I guess let's start. So, as it was explained, I'm going to talk about managing chaos, and I will explain what I mean by that a bit later. I guess I should start by saying what I do a bit more. So, I've been in Uber for 3 years. I'm based in Amsterdam, whatever it matters. I started as a pure software engineer, so I was just writing code and then moved to an SRE around a year ago, and that kind of means different things in different parts of Uber or different companies, but for me it means I am currently managing a bit of infrastructure in AWS. And the funny point, like 3 years ago, the company I worked with had 8 people, out of which 2 were doing like database backups, and now we have around 2,500 people just writing the app, which is a bit insane, I thought. I am on call on pretty much, but that's not unusual because every engineer at Uber is on call. What's a bit unusual is that I'm part of this Ring Zero group that's basically responsible for fading over data centers. So we have around 12 people that are on call, would follow the sun rotations, and if anything breaks, like Uber is down, that's the people who get paged, and then we have like 3 minutes to fix it. And that gets a bit insane, and I'll talk about it more. And then, yeah, still fascinated by complex systems. So the still is in the quotes because even though I've been doing this, I think it's fun. Like, yeah, I think it's crazy and it's scary, and then you can wake up at 5 a.m. and everything is broken, but I like it. It's fun. It's really fun. So the presentation, I would like to show you a few screenshots of what I mean by chaos and how this works. I like it. I will present the problems, touch on solutions, but I will not really give you answers, I think, because this might vary quite a bit depending on what you do, where you are, what's happening. And even us, like we are still struggling. Like it's still a pain, and everything is moving so fast that we don't really. We're afloat, but it's still very much work in progress. Yeah, I'll say what kind of worked, what didn't work, and this is not entirely an architectural talk. So I'm not trying to say like what you should do to make your stuff better. Well, a bit. It's more of I wanted to approach it from an angle where it's how to survive, how not to get drawn by this. I said surfing the chaos. And when I say surfing, it actually means surfing. I mean like staying afloat so that you can still at least breathe when stuff breaks. Because I think with sufficiently complex systems, with so many people working on different things, you just have to accept that it will never be as good as you want. Like it will just, it will just fall apart, the entropy will just pull it apart, and then everything will be just a bit insane. Yeah. So, this is a screenshot from an internal email that someone sent a few months ago. And I'm not sure if you can see it, but when I first saw it, I thought it's a like star map, and I thought it's cool. But actually, it's a rendering of Uber-wide call graph, with all the lines being the calls. And then Populous is our like user store, which pretty much everyone always talks to. And because this is not like, oh yeah, the colors here are different parts of the system. So we kind of have like this like real-time world that deals with cars. There's other stuff like money. There is data. So they're kind of connected, but in the end, like everyone talks to each other. I also made this. And this was made around 2 weeks ago, so it's as light as it gets. And yeah, there's a few clusters of things, but most of things just kind of talks to each other, and you don't really know what's happening. And because this doesn't show everything that's happening, I made it a bit bigger. And I also made it a bit bigger. And these are the services. And when you look at it, it kind of looks like, I guess you know this meme, like you like, I really like microservices. So going back to this, so this is around nobody really knows how many microservices we have. It's like really nobody knows. I've heard numbers between 2,000 and 3,500. And for example, we have this idea about Fix-It Week. So the last Fix-It Week, we've decommissioned around 150 services. And with just people like trying to figure out whether they're used or not. Just nobody really understands this. We are pretty confident that we have more microservices than we have engineers working on them. And I've personally been an outage, or multiple ones, just like this one strange microservice kind of starts breaking, and then it has a cascading failure across all the stack, and it's just insane. And it's fun. Yeah, stuff breaks. And next, so this is a bit different, but I like the drawing, so I thought I should post this. This is in our Golangs, we use monorepo, and we have this set of tools that we use for various things like logging, metrics, UIDs, common tools. This is the dependency graph of those tiny services within the monorepo of Golang. Like, if you want to change one thing, like, good luck. So it's and it kind of grew organically, and nobody really planned this. And I think we've been using Golang for 2 years. So this is like 2 years of work of engineers doing stuff. It works. And this is also, I took the screenshot 2 weeks ago. And this is our distributed tracing for app launch. So every time, so I will talk about this a bit more later, but we have this distributed tracing when on every request, there's this context propagation across all microservices, so that then we can know what's happening. And if you see this 1,879 spans, that doesn't mean there's 1,800 services. It's around probably 600 services touched on when you start the app, Uber, like 600 services. And actually, it only takes 994 milliseconds, which I think is pretty awesome. But if you look at those things, for example, I had some, so Schemaless is our, one of our databases that we use. It's touched 152 times. Like 152 times on start the app. There is also Onyx, which is our read-through cache. So if everything fails, we kind of sell a bit of stale data. 196 times. And the Populous service that I showed in the previous graph, it's touched 31 times. It's called GoPro here because it's like the second iteration of the services. Yeah, 600 services, 900 milliseconds. And this on the bottom, which kind of, I guess, looks a bit unreadable from the back, I'm sorry. It's like the call graph, as you see, as the services call each other. And it's a bit like, by the end, it gets a bit parallel. So that's why we still manage to have 900 milliseconds for all this. But, I mean, it's insane. Like, nobody understands this. Like, nobody can actually figure it out. And there is cross-service dependencies. I've seen people like call the same services twice, and you have loops. And it just happens. And then we are on call for this. Like, this is probably the most important endpoint in the whole app. And what happens if one of them breaks? Like, we don't know. What happens if one of them starts taking 100 milliseconds more than the other, than previously? Your SLAs may break, timeouts will happen, retries. It's fun, right? And this is like my favorite tweet in history. We replaced our monolith with microservices so that every outage. And when I saw this like 2 years ago, we printed it out. It's hanging in the office so that every morning we know what's happening. And yeah, as there's been a lot of talks about microservices around how people push to killing the monolith. And Uber has killed the monolith around a year ago. And is it better? I don't know. It's arguable. Like, if you want to talk about this, I'm happy to talk about this afterwards. It's like a whole other discussion. But I would argue that in some cases, the monolith was easier to maintain and easier to survive than this complex nest of things. I also have, I think, some more. So this is a screenshot from one of probably the most important dashboard at Uber, all of our 400 and 500 errors. And like, what does it mean? you get paged, and you look at this, and those is just different services calling different types of errors at different time, and then you don't really know. And those things might be something like when you browse your trip history, the screenshot of the last trip didn't show up, which is bad, but it doesn't really matter. Or it could be that someone cannot take trips. And similarly, those errors, those spikes, it's fun. It's fun. And to add on top of all that engineering complexity that we've kind of built ourselves, because we were just like adding and more features, we have 700 cities, 80 countries, and most of those things have like different products flows, like Uber, there's Uber Eats, there's various types of supercars, and it doesn't. What I'm trying to say that is that in these cities are managed by the people on the ground. So they sit and they can like tweak their settings, they can increase the radiuses, build different geofences. So at any given time, not only our own services might break, but someone might just enable this tiny feature flag that we built like a year ago, and then suddenly, like everything, it's really hard to monitor. Like I've been in situations where we just couldn't figure out that something was broken for multiple days, but because it doesn't show up on any of the graphs and monitoring, it's just hard. So enough of screenshots, and I've wanted to list a few things that happen most. So we've made this statistic somewhere that like 85% of our outages are caused by deploys. So it's just someone trying to push new versions of the code. We might catch it within 3 minutes, or we might catch it within like 3 months, depending whether on error. And how do you know? How are you confident whether you have not broken something? And one of my favorite type of outages is that I guess we all work with JSON APIs, and in JSON you have what is the difference between empty string and just string not being present? And this has caused like multi-hour outages because someone used a new JSON validator that just removed empty values, and then somewhere in the chain stuff explodes. Similarly, around 2 years ago, there was an outage where someone in a very small service in the 3 layers deep changed a translation string, which was never supposed to be. It was supposed to be there since day one. They added it, and then 3 layers up, someone else was comparing. It was doing some string comparison, and that caused all of our errors. So if you requested a trip, it would just say, "Sorry, something went wrong," because all the error handling would just break because someone added a string to our translations. And then that's how breaking changes just happen. But then even better, like how do you introduce a breaking change? Like technical debts or having old services is, I guess, something that we have to deal with. But there is this time that after a year, 2 years, you just have to kill it. Otherwise, it becomes as a pain. And so you do have to make breaking changes. And like how? So what we usually do is this gradual rollouts of like very tiny percentages and see whether someone starts complaining. 5%, 10% rollback, 5%, 10% rollback, 5%. It's fun. Deprecating a service. Similarly, our monolith killing is probably 3 years of work of 200 people. I personally work on a service that we wanted to kill since beginning of the last year, and it's probably going to stay there for another year because we gradually move all the consumers to different flow. At the same time, we have to backfill the data into like this old, unused format that we don't really care about, but it's kind of related to the, especially problematic with the mobile app versions, because while it's relatively easy to maybe change a website, with our app, we have this policy where I don't know how many nines of people have to be on a new version, but we cannot deprecate the old app. And the old app will just forever make those calls in this weird format that you have to detect the version string and try to behave slightly differently because, well. And then, so something breaks, right? And then you get paged. And you have this call graph of 600 services, and then like So I personally was mostly on core in payments world, and that includes adding credit cards to the app. And that means I get paged if our database is down, I get paged if our third-party provider is down, I get paged if our front-end thing, the proxy in between stuff gets down, I get paged if someone changes translations. It's really, really hard to figure out what's happening unless you've seen it before. And that's hard because you keep adding more people to your team, you kind of keep rotate. And then how do you mitigate an error? And I think that's one of the most surprising points. And I will speak of this later, but mitigation is the key. Like, all this doesn't matter if you can mitigate. Like, if half of your data centers is dead, who cares? Like, I don't care, as long as the users can still take trips. So I'll speak about this more at the end. Yeah, because when I was at uni, I was taught that every presentation is a plan, so I'll give you a plan. I'm going to briefly speak monitoring, alerting, a bit of testing across this stuff. I'll come back to this tracing graph that I showed you at the beginning, mitigation, which is really fun, and conclusions, which are going to be surprisingly vague and, well, not really great. So monitoring. When I started building this presentation, I kind of assumed that everyone will monitor, and there's no reason to talk about this. But then I remember that 4 years ago, when I was like 2 jobs behind, we had 0 graphs. We had 0 monitoring, we have 0 dashboards. What we used to do, we would SSH to production box, tail the log, and try to look for errors. And then as we started building, being more like, what the fuck? Maybe I should say that. We started SCPing logs to our laptops every night, and then building graphs with matplotlib. And we were sending emails to the few select people in the company to solve the graphs. And that was all against our DevOps. So our DevOps people thought that, oh, they're going to build this proper new solution in 6 months. And so they didn't want us to build something hacky. So I guess the lesson from that is that if someone tells you not to build graphs, do it now. Like, ignore them, build your graphs, emit your metrics, have dashboards. It's a must. Like, I would either say that forget about everything else in this presentation, have graphs, dashboards, because you really need them. Without them, it's impossible. Yeah, so SSH to box, tail, and then for comparison, 4 years later, I saw this presentation by our monitoring team, and they ingest tens of millions of data points per second. And what surprised me, they also built this metric, 75 years of time series data queried per second. I don't know what that number really means, but it's huge. And so we have, I was told, 99.98 of metrics we emit are never queried. Like, nobody ever looks at them, but there's so much that it's better to have more than less. And it's really cool. Like, you really need dashboards. But what is my next point? Yes, so monitoring. So when I started doing this, I started building white box metrics. So white box metrics is what we call metrics that we emit from the app itself. And there was this presentation, this room yesterday, about a guy from Bwin about how to do health checks. And he had this interesting point that you should build your health checks so that they only look at the service that you're building without looking at your own dependencies. I kind of disagree. So what we try to build is always business level monitoring. Like, it's cool to have CPU stats, it's cool to have how many requests are happening, but what you really care about is that are the users there? Is it happening? And you should just wake up, 3 a.m., you have one dashboard, open this page, and then you're like, oh, OK, I can go back to sleep. Or you start calling people because something is broken. Like, we really, business level monitoring, the highest you can get. And Google talks about these 4 golden signals that you should look, like errors, latency. It's important, but it's important to help you fix stuff or mitigate stuff. Business level monitoring is awesome because it shows you, like, if anything just breaks, you see it. Yeah. And this one dashboard to rule them all. Like, you just have one dashboard. OK, this is broken. click next dashboard, and you kind of orient yourself into what's broken, what's happening. But it's really important to have like one dashboard, 3 a.m. OK, I can sleep now. But this is not good enough. So what we've kind of built, and while our solution is a bit complex, I've also heard some friends are running like a Tmax terminal in AWS, and they're pinging their service from this external service. So it might apply for smaller services. So what we do is that we have, in 3 public clouds, we have daemons pretending to be users. And they take trips in separate deployments. So if AWS goes down, we still have data. If Google Cloud goes down, we still see that. And it's every 10 seconds, it's trying to take a trip. Like not every city, because some cities are so small that would basically overflow the cities. But it allows you to test different flows at various resolutions, different times, and it allows you to actually have bigger understanding of what's happening. Like users cannot sign up, users cannot add credit cards, units can take trips, the receipts are not being sent. It just literally pretends to be a user. Oh, it's per city, which is a bit important for us because with 700 cities, when you compare London and Vienna, or even some smaller, I'm from Krakow, so the traffic is huge. Like it's 1% versus of the global traffic. So you really, if you care about it, you really have to have special alerts per city, which this allows you to do. And then it sounds OK, but then there is also problems with, because you're pretending to have fake users to take fake trips. What if you change your APIs, or if you change your app, and then everything kind of falls apart? So we have a few teams that mainly do this, and it's responsibility of the people who change the API to also change the tests, which I think is the right way. And then how do you differentiate test data? Because we have, if you have trip every 10 seconds in every city, I think someone said that it would be like 40% of, it's just a lot of traffic. And it affects your metrics, affects your like P&L, potentially if the data sneaks into wrong data stores. All this stuff is complicated. And then overloading small cities is always a problem. Also, we have this dynamic pricing. And then if in a small city you try to take a fake trip every 10 seconds from the same spot, our data machine learning will assume this is like the best place to go in that city, even though it might be just a test city. So yeah, I mean, you have to have both, but each of them comes with its own problems and benefits. And then similarly, alerting. Like how many people should get paged if something breaks? Should it be 1 person? Should it be 10 people? Should you, if you are responsible for like a flow of adding credit cards, and then a database that you don't own breaks, do you page those people? We currently page pretty much everyone, just in case, so that at least 1 person wakes up and tries to fix it. But it's a bad thing for on-call health. Similarly, one single broken service can cause 1,000 people to get paged. And I'm pretty sure that around 2 years ago, we managed to break PagerDuty because something broke, and there were so many pages that pages stopped arriving because there's thousands and thousands of things per second. How do you find the root cause and the right team? And I will actually have answer to that question maybe in a few slides. And then if you get paged, it says, OK, users cannot take trips. And then it turns out that a business development people has enabled a new flow that allows you to take trip without taking cards, and then it kind of breaks 7 layers in, but the error code that you expect is different than the Node.js frontend that you have, and then everything just throws up 500. Also, what would be really cool is that, so you get paged, and then the tools that you have should tell you the likely sources of it. So you know what you did, you know what you changed, but how do you know what other people changed? And this is actually a problem that is solvable with technology. Like nobody understands this, and nobody can really see this in their head. But you can build tools that show you, this is your call graph. This has changed 10 minutes ago. This has changed 20 minutes ago. Maybe you can even roll it back automatically. So even before you get paged, the system says, OK, let's try to pull this back and see what happens. Similarly, so what we had in the past was that as those teams kind of grew independently and everyone was pushing for speed and let's have new features, everyone was building their own dashboards and their own way of having alerts. And that was awesome for a certain level, but as soon as you get a bit higher, then you actually don't want that. You won't have to have the same data for every service. You want to have the same alerts. You want to be able to understand. And so we actually have a few people that their job is to define how do you build dashboards, how to build alerts, how do you make it so that not everyone reinvents the wheel. And testing. And does anyone, I don't know if I should say a game, but I was building this graph and I thought it's like the 3 Musketeers, because one for all and all for one. Because I'll talk about this more, but it appears that if one of those services that in your chain doesn't do what you expect it to do, your whole testing framework just disappears. So, for example, one of the common, we've tried staging. So historically, we didn't do staging. We kind of tried testing production. Now we're trying to build staging. But then you have to make everyone have staging. And then you have to make sure that every single person, when they deploy to production, has staging up to date. Because if you have a chain of 100 services and one is not up to date or one is broken, someone was 6 p.m. on Thursday, I'm going to just test whether this works. Oh, it's broken. OK, I'll fix it tomorrow. And then your whole integration tests break. So with 5 services, someone needs master dirty, it's broken. And then so you want to do a deploy, and then you want to test on staging. You can't. What do? Do you wake them up, especially in the different time zone? Do you block your own release until the next day? And what happens if it's 15 services or 50? And then each of those errors kind of has bigger impact. And it appears the answer to that is some tooling and some engineering culture. So most of my talk will be talking about like technical problems to fixing it, but culture is really important, and you really need to make sure that everyone in the company like appreciates, understands, and like every person is doing the right thing. Like no deploys at Friday 5 p.m., no broken code master, and it just takes time. Like it really takes time and weeks and months of talking to people to make it work. And yeah, that's actually part of my job as the evangelist of reliability as theory. Also, staging. So some of our services run in like thousands of nodes across data centers. You have staging. And then do you also keep the same staging? Do you have smaller? Do you auto-scale, maybe? There were outages that were caused by, it's really artificial traffic. Like you cannot just take a 10% of your traffic and send it to staging because it will just not work. Like there is dependencies, there is things that you don't expect, like you're running auto file descriptors and all these kind of things in the lower level of your system that you don't expect. So you actually have to test it helps you, but it's not good enough. And then how do you generate real load? So for us, historically, it's been the New Year's Eve was a bit of a crazy event because everyone was taking trips. And what would happen is that the graph would have nothing, and it would be this massive spike of 3 times traffic before the New Year's. And everyone was, for the 2 months before, just trying to generate this test traffic so that we can test things. But then if you have the same user taking 100,000 trips, or do you have 100,000 trips taking 100,000 users taking a single trip, you have to kind of have an ability to replay the traffic that was actually representative of what's going to happen. So staging is cool, and it really helps for some things, like you can run integration tests, you can verify load, but it's not good enough. So testing in production. So around 3 years ago, We used to do port forwarding, so SSH to production, open a few ports, make some requests, you have depending services, everything works, and that was awesome for quick development, but no. But maybe we can do this. So what we are actually building is that we have this auth proxy in between your laptop and production services, and you can whitelist a few of those endpoints in between you and production, and then some of the endpoints you can talk to, some you can't. You can also whitelist specific test users, so it only talks to if you're using that. You can also whitelist endpoints, and then it's even more crazy where we have the ability to pretend that you are a production service. So if I was to log in with my Uber app, everything would work with production services, but this one particular service could go to my laptop and just see what's happening. And that's really complicated and takes years to build, but it helps. But another thing, can we do better than that? Yes. So what we do is we do tenancies. So we have every single user, every single request, every single trip has this flag on them saying whether you are test or not. That means we can replay everything. We can do real traffic. We can test actual production services. But we can have separate metrics with them, separate dashboards. It is important. But it's also complicated. And I just realized that I'm actually way slower than I thought I would be. So I will speed up. I apologize. Automated testing. You don't really want to be running tests. So we have tools that allow you to trigger tests whenever a deploy happens. This is great, but then do you need tenancies or do you test production stuff? Or can you just load your service at any given time without affecting the downstream services? And if you use production, you want to load test until this breaking point and just stop just short of it because you don't want to break it. Similarly, you want to make a test when you deploy, but maybe you also want to take a test when your downstream services deploy because they might break something. Or maybe you should deploy whenever your upstream service makes a deploy. So in the end, you kind of end up having this continuous test running all the time, 24/7. And then even like, how do you know what's your service? How do you know what's happening? Solution, I guess, is you need it all. I think in our case, I didn't spec out unit tests. We need them, but I assume that everyone does unit tests. Please do unit tests. We do this individual testing against prod during development. We do integration tests for like, okay, this kind of works. Then we have staging, and then we do this automated, and then we do this tenancy test with full flows against production pretty much daily to verify this works. And then before big events, we have this hundred thousands of artificial users taking trips against endpoints. And then distributed tracing. So this is cool in itself. So as I said, you attach a bit of metadata to every request, you propagate it across services, you know your call graph. And that kind of feels cool in itself because you can see, oh, something broke. So this is one of the endpoints that we do. You can just see. But this also turns out to be like the meta tool that allows you to use other tools. Because with that, tracing stuff is awesome, but this is the missing piece. Because this tells you what your dependencies are. This tells you what breaks. This allows you to discover what's happening. It tells you, like, if you know that someone else got paged, and you are in a chain of this, maybe you don't have to get paged. Or maybe if someone made a deploy, and then you know the dependency, you can roll it back automatically. You can test things, and I think this was like the biggest discovery for me in the last year, because this is how we basically remove humans from the chain. This is how you build knowledge of the system so that you can actually use the system itself without people doing it. But then it takes years to create. It takes years to build tools that will actually be able to use it. And then it takes years to teach people to use. Like, we've had this for 3 years, I guess. And it's really hard to even to kick it off and have it as important as it really is. So mitigation. So This is surprisingly. So we interview, like I interview everyone at Uber interviews, and then we occasionally ask people for this role-playing game. So imagine that you have an outage, you see these errors, what do you do? And then 99% of people start wrong. Like they immediately, they try to debug, they try to understand, there's this instinct in every one of us, I think, okay, I see this error, this is 500 from this service, this is what's happening, okay, so I have to like clean this temp file for this. It's wrong, it's all wrong, you should never do this. You should always, oh, I broke my slides, sorry, it was supposed to be this. So, prevention will fail, but you don't want to be fixing stuff. What you want to do is to mitigate. You want to have tools that help you mitigate customer impact without actually fixing it, because it doesn't matter if it's broken. So, so you have to have tools. You have to have this dashboard. You wake up, you see what's happening, you make a decision. Boom, okay, I know. I'm gonna now turn off the service. I'm gonna, you have runbooks for this. So in our case, in my team, for every single page you get, there is this link you click this link, and it tells you, okay, if this error is happening, click this button. If this error is happening, and this error is happening, run this script. If this is happening, call these people. It's really good. Like, it's really, really good to understand what's happening. And then it also depends on the team that you're using. A lot of people don't. This is also quite surprising. For example, in payments, where when you take a trip at Uber and then the payment system is down, so we cannot verify whether you have a credit card, we allow you to take trips. You can go pretty much for free. And this is the assumption that it's our fault, we broke it. It's better to allow people to take trips and do stuff rather than to prevent them. Similarly, for example, I know in Uber Eats, when you look for restaurants, when something is broken, we just shrink the radius of the available things so that we degrade the quality of the system so that it still stays up. But it's really hard to do when you don't know you can do this or you haven't planned for this. So you need to have this planned upfront. And we use this thing that's called OdaLoop. It was apparently made for US Navy, like Orient Decision Act. So it's this continuous loop of you figure out what's happening, and then you look it up on the link. It's kind of cool. Like it pushes you to this workflow. Okay, what's happening? What do I do? I'm doing it. Did it work? No. Okay, what do I do? What's happening? And then trainings are surprisingly effective. So I'm going to speak about it a bit more in the end, but you have to train. Like when I started being this Ring Zero, we've had this weekly trainings where we would sit in a room and we would just simulate failures and we would try to push the system to failure and then see how it behaves, and then you just train. You train how to communicate. Surprisingly, even communication with people during an outage is critical. Like, you have to be able to crisply decide what's happening, tell them what's broken. You have to be able to communicate, you have to write it down, you have to be able to execute using your tools. Yeah, so that's what we kind of did, and it was amazing. Like, it really changed my mind. So we are on call for data center failovers, so if everything breaks, we just turn it off. We have tools, web-paged, where something is broken, and because of what we do, we kind of end up being this implicit commanders, like, because we've seen this so many times and we've trained for this. Your mindset changes. You're no longer panicking. You're like, what's happening? Okay, how do we fix it? Who do I need to talk to? It's just training. In different roles, so you have to practice talking to people, you have to practice communicating with people, you have to practice looking at the graphs. You have to have tools. So right now, if something broke now, it would probably take me like 2 minutes to disable data center, because I know where to go, I know where to look. I have this big red button, I push the big red button, everything changes. Yeah, and we train this on a weekly basis. And our runbooks, one of the first things is kind of brutal, and I guess people don't like us, but if something breaks, I click a button and nobody in the whole company can deploy. Nobody in the whole company can test. Nobody in the whole company can run a load test. Nobody in the whole company can change dynamic configuration. Everything freezes. And this is so that our failure domains, which in likewise is data centers or regions, depends how you look at it, and then it just stops. So you have a chance to figure out what's happening before the failure spreads to other things. And it's also kind of important that we try to, like, our Puppet runs are 24 hours apart, so that if something breaks, you can still maintain it. Reliability. Okay, so I didn't talk about unit testing or chaos testing. We do that. You should do that. It's cool, but different talk. Similarly, we try to teach the culture of the incident. So for every single incident, we write postmortems. We get to a room. We try to describe what happened. We try to fix stuff. We have incident reviews with various levels on org. So sometimes just within the team, sometimes within the org, sometimes with the CTO. These are not fun. On-call health is really important. So sometimes you actually want to page less rather than more. And I'm really out of time. Didn't talk about libraries. Capacity planning, this is insane. It takes so much time. It's so undervalued. But every month you just have to figure out, okay, how much capacity do I need for next month? Similarly, SLAs. This is actually, I think, one of the most important steps. So some people try to, rather than trying to understand the system as a whole, I believe that if each of those services defines a very clear SLA that I'm going to return 4 nines for these errors, that would just immensely help the system to get better. Similarly, you have to know what broke and you have to keep track. If that team keeps failing every week for everything, you have to be able to tell them that, hey guys, this is not cool, make it better. Conclusions. It's fun. You should do this, it's great. Everything I said might or might not work for you. Some things, even within Uber, some teams have more staging, some teams have different approaches. Depends on how can you degrade gracefully, how critical you are. Maybe it's okay if you fail for 12 hours. You need tools, and you need tools, meta tools, to help your tools actually work. Engineering culture, critically important. People have to understand what's happening. Everything should be automated. And then I just put this one slide, and this is about maybe our future. So I don't really know how to fix this, but this is AWS front page. So how we try to solve this cross-cluster dependencies is that we try to build these APIs where we pretend that we can just enable simple features for other companies, and that allows us to build clusters of independent features that then pretend to be cohesive independent system rather than having this mesh of hundreds of microservices talking to each other. And I'm sorry because I was planning to ask questions, but you can talk to me afterwards. I'll be here if it's
Thank you, Paweł. Yeah, as a matter of fact, we have now half an hour break, so if you're still interested, we could get some of these questions answered. If not, please just try to be as silent as possible when leaving the room for the people who still want to hear the responses. So, first question, are you on call right now?
I was on call until 8 a.m. I was on the page, and I disabled it, and then I will be on call again after. I mean, not on. So we have. Oh, what's happening? It's not me. Wait.
It's okay. Don't worry.
So we actually have on-call person that is always responsible for being on call within 30 seconds. The second line. I also get paid because I want to. So starting in an hour, I will get paid for every Uber failure. Maybe I can just jump in and try to fix something.
Okay. And the last question: do you really need such a large number of microservices?
No. Like, absolutely not, and you should absolutely kill them, and you should absolutely keep it. I actually like monoliths. Our monolith would deploy in 8 minutes across the stack. It was so polished. It was awesome. But you need some, but definitely not, and it's mostly culture. Like, you just have to, people have to understand that, yeah, even last month, I spent half of my time fighting DNS because we had DNS issues. And if we only had less services, then you could just talk inter-process instead of doing all those RPC calls to what is the phone number of the user, let me talk to the standard microservices, you know.
Thank you again.
That's it? Sure. Okay. Cool.